Hi guys, I'm Darren, and in this video I'll be showing you how to set up iNav 4 Red Kite. So you may notice from the introduction I'm saying iNav 4 in general, not a 4.0, 4.1, whatever. And that's because the way the version numbers are now changing, we should safely be able to use the same setup process for any iNav of version 4. I mean, chances are most of it will probably still work in version 5 too. But anyway, I just wanted to generally encapsulate the whole iNav 4 version rather than just specifying a minor version. So let's get started. Now, there are a couple of things I want to bring up while we do this. First of all, I have written an article on my website, and you can find it if you go into Flight Controller Therapy and a complete setup guide to iNav 4 Red Kite. And I will be sort of following along with this article while I'm making this video. And while I'm at the website, I may as well mention my pre-maiden checklist, which is also really useful if you've built a plane or updated a plane. You can go through this checklist and make sure that iNav is basically set up so that you should have as minimal problems as possible. Right, so those bits out of the way, the next I wanted to talk about what I'm covering in this video. This is really just about setting up iNav. I'm not going to be going through the build process of a plane. I'm not going to be going through a process of setting up modes on the transmitter. That's sort of prerequisites for this video. I do have videos out there on combining switches to get all your modes on one channel, which is the best way of doing it with iNav, rather than having individual RC channels for modes. And there's also the iNav fixed wing group OpenTX models, which basically have all you need. If you're a beginner to iNav, I'd highly recommend checking out the iNav fixed wing group standard model. This gives you a basic switch layout and also has a few little tricks in there to try and get you in some good habits for when you're flying. As far as a complete build series, I'm not the quickest guy at building planes, but if someone wants me to do a complete build series, it's something that I am thinking about, but bearing in mind it might take a little bit of time to get done. But what I'll do is find a popular and beginner safe plane and just build everything from scratch. So if anyone's interested in that, leave a comment in the video description and I'll listen to what you guys' thoughts are. So what I'm going to do is break this down into two sections really. The first is stuff that we should really be doing before we even put the flight controller in the plane, and actually before we even solder a single thing on the flight controller. And then after that we'll move on to once the plane's been built and how to get everything set up as far as iNav is concerned. So what we'll do in a minute is head over to the workbench, do the pre-installation side first. Then after that, I'll cover a few things to watch out for in your builds. And then we'll get a plane on the bench and we'll carry on the setup process until we're in a stage where we're basically ready for our maiden flights. But before we do any of that, we actually need to get hold of iNav. So this is located on a website called GitHub. I will put a link in the description. And what we have here is iNav Flight, iNav Configurator. Now, you don't actually download the firmware itself. You download the configurator, which is how we change settings on the firmware. But the configurator has a drop-down list of the firmware that's available to flash. So you just select that from the list and put it on the flight controller. Of course, we'll be showing you that in the video anyway. But now, while we're on this GitHub page, where you want to go is this releases option here. And this is actually a pretty good time because there is a release candidate up. Now, if you're completely new to iNav, ignore the release candidate. Anything that has this pre-release label next to it, if you're a beginner, if you don't want to risk your plane by testing new features, ignore that release. What you want to do is scroll down to the first one that says latest. Now this one here is the latest stable release. So at this point in time, it's iNav Configurator 4.0. I'm actually going to be showing you how to set this up on 4.1, but as I mentioned, it doesn't really matter what I show you because the setup process is the same. The only thing is you should always use the matching configurator and firmware. This has been the case basically the whole time with iNav, but people have been getting away with it in the past, but really you should use the same version. So if we're using 4.0, we should be using 4.0 configurator and 4.0 firmware. And likewise, if we're using 4.1, we should be using the 4.1 configurator and 4.1 firmware. The great thing with Configurator is you can have multiple versions on your computer. So you can have a plane running older iNav firmware and put the latest version on your new plane. You can always just run the configurators. You just don't run them both at the same time, because then it confuses things. You can have multiple versions on there, and they're always available to download on the GitHub. It does just take a little while to search down through the list to get the older ones. So what you need to do to download it, so I'll show you with 4.0 because that is the latest stable release. You look in this assets box and you can see here there are different versions for different computer platforms. There's Windows 32-bit and 64-bit, there's Mac OS, and there are Linux 32-bit and 64-bit. Now the Mac OS is actually a signed application, so you can run that with no problems whatsoever. But I'm just going to choose Windows 64 because that's what I'm using here. So you just click on it, download it to your desktop or wherever you want to put it. I'm not going to click the save button because I already have this, but yeah, you just click save and then it will put the folder on your desktop, and that's where we'll go next. All right, so here we have the zip file on the desktop, and all you need to do is open that up, and inside there's an iNav configurator folder. If you just drag that onto your desktop, it will just extract that data to your desktop. But once you have this iNav configurator folder, we can basically run it here, or you can put it away somewhere and create a shortcut, whatever you prefer to do. But one thing I would suggest is renaming the folder. So I actually put the version first because it's easier to see if it cuts text off. You'll notice I've labeled this folder 4.1. As I mentioned while we're on GitHub, I'm going to be demonstrating with 4.1. And the reason for that is by the time this video comes out, there's a very good chance that it will be the current stable release. So I am actually showing you with the latest version. If not, it will be days, weeks at most. So this process, as I say, will still be the same in iNav 4.0 if you're using that version. But what we want to do is just open the folder, and this iNav-configurator.exe file is what we run. Again, it may have a different extension on different platforms, but it's the iNav configurator file that we want to run. If you're on a PC, you may well get this message. Just click more info and run anyway. That will be the only time you see that message. Once it's running, it's all good. So this is our iNav interface. Now, there's a good chance if you're new to iNav, this is the first time you've seen it. If you're coming from quads, you may have used Betaflight, which looks very, very similar. But what I would say as a word of warning, if you are used to quads and you're used to Betaflight, other than the very, very basics, put that out your mind. There have been lots of issues where people think, oh, I know how to use Betaflight, I can set up iNav, no problem. And they just miss little things that are important. So please, if you are coming from Betaflight, give it that little bit of respect and take the time to learn how to use it. As I mentioned in the intro, there are a couple of things that we want to do before we even solder on the pins. As you see, I've already done that, but I have tested this flight controller prior. So this part of the video I would recommend doing as soon as you take it out the packet. Don't even solder anything on whatsoever. That way, if there is a problem with the board, you can quite happily send this back for a replacement, and there's no arguments. You've not done any soldering to it whatsoever, so there is a genuine board fault. If we start soldering things on and we mess something up, then there's a lot less chance that a shop or anyone else is going to take it back. So what we're going to do is a couple of setup options, but this will prove that the board is working. So then we can safely solder on our pins or direct solder our wires, whichever our preference is, and get it in the airplane. All we need for this is our flight controller and a USB cable. So let's head over to the workbench. Oh, wonder who left that there. Okay, so this is a Maytech F405 WSE, and I'll be using this for the first part of the demonstration. The flight controller that will be in a plane is already in a plane, so it will be slightly different, but the process is exactly the same. This has a really nice beeper switch, so I've got that switched off so it won't annoy us. But all we're going to do is just plug this in. So you can see we have lights on the flight controller, and also on the configurator it has found a communications port. So that's a good sign already. We've connected up, we have a communications port, and it is talking. And the first thing we're actually going to do is try to connect. Now I know that this should work fine because I'm on 4.1 with it. If you're not on a version that will work with this configurator, it should just go to a blank screen that looks like this, and you won't be able to access any of these other components. This is fine. This is the CLI, which is command line interface, and what that does is give you access to every parameter on the flight controller's firmware. This is talking directly with the flight controller. But the only thing that we're interested in at the moment is to find out what target is on our flight controller. So we will type in version and press enter. Now you can see here we're already on version 4.1. As I say, I don't care. I'm going to be completely wiping this in a sec as if it's a brand new flight controller out the packet. What we are interested in is this bit of text right here. If the first bit here says iNav, then we can use what's on here and we don't have any issues. If it says something different like beta flight, then what you may need to do is go to the manufacturer's website and find out what the iNav target is. Sometimes they are different, so you can't really just rely on what's written here. If it says iNav, the other side of the slash is the target name. So this target is the Maytech F405 SE. So we know exactly what we want to flash on there now. Like I said, if it doesn't say iNav, you will need to find out the target from the manufacturer. So once we have our target, what we're going to do is disconnect, and we're going to go to firmware flasher. Now for you guys, this is exactly how you want this set up. You want no reboot sequence off, full chip arrays on, and it's worth having that on even if you do an update. There is a diff process for the update, which I will show in another video. Basically, every time you want to do a full chip arrays just to get the default settings from iNav. This way, if anything has changed in the CLI, it does get reflected. Leave manual board off so it's automatic. And for you guys, if you are new to this, make sure that this is turned off. This is to show you the pre-releases, which again, if you're new or you don't want to test new pre-release software on your plane, leave this switched off. Because I'm using 4.1 and at the moment it's not a stable release, I will be turning it on for this demo, but just in your case, leave it off. And as I say, when this video comes out, there's a very good chance iNav 4.1 will be stable. I just want to show you this version because it will be more familiar going forward. And what we're going to do is, you can see the list of targets is actually pretty long, but we can actually shorten that list down. So I'm going to put in Maytech, and now we just have our Maytech flight controllers. So our Maytech F405 SE is nice and easy to find. Next up, we're going to choose which version of the firmware we want. Now, what you should do is download the latest stable release. If you haven't checked that box, you won't see any of these release candidates anyway, so you can just choose the top one in the list. So at the moment that is iNav 4.0.0, but as I say, I'm going to show you with 4.1 just because I'm a rebel. No, seriously, I've been flying 4.1 for a little while, so I know that for me it's safe, but honestly for you guys, if you're new to iNav, just use a stable release. Right, so the next step is to click the Load Firmware Online button, and this will pop up the release notes for the firmware. Now, this is more important in an update because you will have upgrade instructions here in the release notes, and also what's changed. If you're doing an update, it's very important to read these release notes and understand what has changed and what you need to do to make sure that your old setup is going to be compatible with the new setup. Again, it's outside the scope of this video, but what I will do quickly is show you where to find the release notes. So if we go back to the root of the iNav GitHub, and again, we just click releases. And there you go, you'll find the release notes. So this is release candidate 1, which again you can see is pre-release, but this is the same release notes that you see in Configurator. This is the latest stable release, and again these are the release notes. So what we can do now is just scroll to the very bottom. We get this grey bar here, and this is going to show us our update status. So what we should be able to do now is just click Flash Firmware, and hopefully we won't have a problem. But if we do, I'll show you how to solve them. If we don't, I'll show you how to solve them anyway. Excellent, we've had a problem. Right, that might sound weird, but it means that I can show you how to sort this out. Right, so this is probably a simple thing to sort out at this stage. It just can't get into DFU mode. So all I'm going to do is unplug the USB. I'm going to hold down the DFU button, and I'm going to plug the USB back in again. And we can already see that on our firmware, DFU is now enabled. But if you do that and you find that it still doesn't work, there is something else we can do. So I'm going to just unplug it and just plug it back in again without holding the button down, just so that we're not in DFU mode. And what I'm going to do is minimize iNav for the minute. And what we want to do is get hold of a piece of software called the Impulse RC Driver Fixer. Now the easiest way is just to type it into a search engine. I will put a link in the description, of course, but you just want this downloads page here and driver fixer. So just click on that. It will download the exe file. Just put that on your desktop and we're good to go. So here is the Impulse RC driver fixer, and you just double click to run it. If you do get any messages like this, just OK it, because it is safe to run, and it will just find the flight controller, put it into bootloader, and then exit, so that we're at a stage where we can just flash the firmware. You can use another program called Zydig, and to be honest, I just don't find it as simple or as easy to use as the Impulse RC driver fixer, so I just use that all the time. And it is a really useful tool, because say for example you try to update your transmitter and you have issues with it. Like there was an issue going around with the X12S where people would try and update OpenTX and think that they'd bricked their transmitter. Running the Impulse RC driver fixer and then updating the firmware in a slightly different way actually got everything back and working. But you can see that's closed, so let's go back to Configurator, and you can see we're in DFU. So now we can just click our Flash Firmware button. It will completely erase the flash on the flight controller, and after that's done it will install the new version of iNav, and I'll come back to you at that point. Okay, so we're back, and it just sits at this screen. You can just see it says programming successful, so we know that we're all good and we have our basics set up. Now we're just going to connect to iNav for the first time, and we get a defaults dialog pop up. At this point, we need to choose what type of plane iNav is going into. Now, there are two options that we're going to look at: aeroplane with a tail and aeroplane without a tail. So if you're using something like that dart over there, that is an aeroplane without a tail. If you're putting it in something like a mini drac, again, aeroplane without a tail, S800, aeroplane without a tail. You get the point. If you're putting it into something like an Albabird, mini crosswind, He-wing T1 Ranger, that is an aeroplane with a tail. A mini drac boomer is an aeroplane with a tail. So there you go, you can see the differences there, and on the website article there is actually a list of example planes. For this example, I'm going to be putting it in an aeroplane with a tail, and as you can see, I'll be a glutton for punishment. So we'll just click that and it will apply the settings. The main differences at this point is the PID side of things. It's got slightly different PID numbers for a tailless and a plane with a tail, but in the future there could be slightly more differences. So we've now done our basic setup, and what we're going to do now is calibrate the accelerometer. Now this was always one of the top reasons for doing it outside of a plane, because it is quite simply easier. With this type of flight controller with a double board, it's even easier still, because we actually have an edge to put it on. but I will show you a couple of little tricks for getting it even with a flat board. So all we're going to do is I'm just going to sit that on the table and we're going to go into calibration. We just click this calibrate accelerometer button, and the first time it does it, it just shows a message basically telling you how to do it. So the first position you want to measure is just flat, and click calibrate accelerometer. Once that's done, we have a tick in the box. Now we can just do these different positions, doesn't matter which order we do them in. So as I said, this one is nice and easy. I can just put it on the side like that and click the calibrate button. But if you're dealing with a flat single board flight controller, you can use something like a box just to get that angle. So let me put that way up, hold it against the box. That's got our 90 degrees, and calibrate. We're going to rotate this way, and again I'll hold it against the box. And the last one is a bit different on this because it's got the cable coming out of the bottom, but all I'm going to do is sit it on the box just so the cable's out of the way. And now we're left for our last position, which is upside down. On this one, it's going to be really easy. I've put these extra long standoffs in here just because I want to try to build a 3D printed thing to go on here. So usually you don't have this luxury. But what I usually do is, obviously this is a table. I will actually put the flight controller under the table and hold it up to the bottom of the table. That way it hits basically 180 degrees to this. But because I've got those standoffs and it'll be easier to show on camera, I'm just going to do that and click calibrate. Once this comes back, you have this calibration finished. Just click on OK and save and reboot. Right, so that is our calibration finished. And a lot of tutorials, if they show how to do this outside the plane, will say at this point, put it in the plane. But I'm going to be different. Because there's something else that is much handier to do before you even solder anything up, and that is set up the mixer. So we're going to pop into mixer and we're going to choose our platform. Now that flight controller is actually going in a flying wing, but the plane that I get on the table in a minute is going to be a VTOL. So I will choose that, and we're going to do load and apply, save and reboot. And again, this is just applying the mixer to the flight controller. And once we've done this, we can then sort of install it. But the reason we do this is to find out where to solder on our servos. If you're using pins like this, it's not so bad because you can just unpin them and swap them around. But I have seen a lot of people who have had their flight controller, soldered everything up, put it into iNav, and then found out that they're on the wrong pins. So what we can do instead is find out what pins we need to solder up before we even do it. So we can see here we have stabilized roll, then we have our VTEL, stabilized pitch and yaw, stabilized pitch and yaw. And we have our servo numbers here. This is new for 4.1. They start at 1, which is much more sensible. So we have servos 1 and 2 for our roll, 3 and 4 for our VTEL. So there is a graphic here, which in most cases will actually match up just fine to this, but there are the odd cases where if you're using a more standard flight controller or something from a quad, the numbers may not match up. So it's worth just making sure you understand how to use this output mapping table. I have done a video on mixing, so I will put a link to that. It will cover this in more detail. But basically, we're just matching the function here. So that is servo 1, which is servo 1, and that is the output pin, which is S3. Now, if you have the same function on 2 different servos, it will start on the left side, then go to the right side. So S3 is going to be our left aileron, S4 is going to be our right aileron, S5 is going to be our left VTEL, and S6 is going to be our right VTEL. Of course, if you're using a different layout, for example, a regular aeroplane, we have to click load. We have servo 1 is our pitch, so S3 is actually our pitch. are elevator, S2 and 3 are ailerons. So S4 will be the left aileron, S5 will be the right aileron, and our rudder will be on servo function 4, which is S6. So this table here is really what you want to use to get everything working well. And once you can see these output pins for your particular setup, you can safely put the servos on there and you know it's going to be right. So at this point is when we will start building our plane. Now, as I mentioned in the intro, there are a couple of things that we need to take note of, and they really are just where we plug things in on the flight controller. So we need to make note of the UARTs that we use for our receiver, GPS, SmartAudio, whatever you put on a UART, just write it down on a bit of paper so you have that in front of you for the next part of the setup. If you use any ADCs, like for an analog airspeed sensor, for example, also just make a note of that. And that way we don't have to sort of dive deep into the plane potentially to try and see what we've wired stuff up to. We can just set everything up on the ports based on what we've written down in our notes. So it just makes life easier. But just remember that as you make your plane, and I will see you soon. Okay, so we're back, and as you can see, I am a glutton for punishment. I decided to show you how to set iNav up using a 1.2 meter wingspan twin. Yay! As you can see, it takes up quite a bit of space on the bench, but it's all good. Everything that I show you here will apply to whatever plane you want. The basic setup is still the same. Obviously, there are things that are different for individual airframes, but the basics are pretty much the same. So just in case you want a bit of information, what I've got in here, we have a Maytech H743 Slim, which is hooked up to the F722 PXW PDB. That combination works amazingly well, and it's a shame that Maytech have discontinued that PDB. It would have been much better if they just changed the screen print so it was an H743 Slim W PDB, because it works so well. I have an AKK X2 Ultimate VTX under that wing. I have an R9 Slim in this wing. I have a TBS M8.2 GPS under here. I've heard mixed opinions on these. People are saying that they're crap, people are saying that they're good. They look to be rebranded BN220s, to be honest. That's why I went for it. I couldn't actually get hold of a BN220, especially not in the time scale that I wanted, so I just got hold of this because it was available in a similar price. But from my experience, it seems to be working fine. Everything else is the P&P kit, so P&P motors, P&P servos in the ailerons, definitely. I may have updated the V-tail, Cadax Ratel in the nose. So there's nothing really different to what you'd find in most builds. I mean, fair enough, a receiver might be Crossfire or something else, but the setup is very similar, and I will be showing you a couple of things along the way to help with the setup if you have different components. Right, so the first thing that we need to do is check our board alignment. Now with this, I have got the arrow pointing forward, so there should be no problems whatsoever, but I will show you now how to check it. So we just stay in this setup page. If we click reset Z-axis, it puts the tail of the plane towards us, so we can do things now like raise the nose. And all we're looking for is that the nose on the model on the screen raises as well. Same as if we bank it this way, it should basically, whatever you do to this should happen on screen. So that is looking absolutely perfect. There's no issues there at all. And to be honest, I wouldn't expect any with the arrow pointing forwards. Some people ask, do I need to correct these? Ignore the heading. You can see there is a slight difference in pitch and a very slight difference in roll. The thing is my desk level? If you can get this thing dead level, then you could update the pitch and roll to get that at 0. But if it's only off by a tiny bit, I honestly wouldn't worry about it. But if you're really anal about it, you could get a spirit level out and level the plane up with blocks just to get the bubble dead level, and then change the values in here. One thing that you don't need to do in here, if you're used to doing it with older versions of iNav, is set up the extra sort of 5 degrees of nose up to get the angle of attack correct anymore. You don't do that in here. It is purely for board alignment sat in the plane. for this model, I'm saying that that's all good, so we can move on to the next thing. If you do need to change your board alignment, or you've even installed it at a really weird angle, I do have a video on board alignment, so I'll put a link in the top corner and I'll put a link in the description. If you need to visit that, pause this video, open that video up in a new tab, and yeah, go through that process, then come back here to carry on with the iNav setup. Right, so as I mentioned, we don't need to add anything in the board alignment for the level flight. What we do instead is go to PID tuning, mechanics, and there is this fixed wing level trim. Now, I will just add a couple of degrees in here just to give it an up attitude as our default setting. But what we will do instead is use the auto level mode in flight to tune this, and it works really well, so there's no reason not to use it. I have it on a switch as a tuning mode. If you're cruising at different speeds, you can adjust the angle of attack based on your current flight speed, so it's really handy. The way I use it, I tend to fly around at like my general flying speed, put it in angle or course hold, turn on the auto level, leave it hands off for maybe 10 seconds or so, and what you're looking for is the digital variometer to sort of settle. It may go up and down by maybe 0.1, 0.2, something like that, but it usually settles really nicely. Once it's at that stage, turn off the auto level and carry on flying. On to the next thing now, which is the ports. So we'll go into here. Most flight controllers will have a default port for the receiver, and if you're using a Maytech flight controller and following their wiring guide, you will already be on the right port for the receiver. Now, just as a side note here, usually the defaults are actually set for FreeSky receivers running S-Bus. So if you're using something like Crossfire, you may find that you don't get telemetry, and this is especially true on F4 type processors. So what I'll do is show you now how to get around that. So this here is just a screen grab from the setup page that on my website, and what you can see here, this is actually on an F405 wing, and we have our serial RX set up on UART2, which is absolutely great. We can wire everything up to UART2. Even if we're using Crossfire, that's absolutely fine. But if you are using Crossfire, what you need to do is set this smart port to disabled. Otherwise, you will not get telemetry through. It will think it's smart port, set it up as a soft serial. So just set that to disabled, and then UART2 then becomes a regular UART. Of course, if you're wiring up Crossfire, you don't use the S-Bus pin, you would use the normal UART RX pin. Other than that, everything should be fine. So now we need to set up the rest of our stuff, and this is where the writing it down on the notepad is handy. So for this plane on my UART2, I've got my GPS, so I will go into sensors and select GPS, and on UART4 I have SmartAudio. That's all I've got set up on this plane. Like I say, if you have more peripherals, you can set them up as you want. There's 8 UARTs on this thing. Right, there's a couple of things I want to make note of on the ports page. The first thing is these MSP options here. Now, never ever turn it off on the USB. If you turn that off, you will not be able to connect to your flight controller via a USB port. Simple as that. It just won't work. So always leave that on. And I would also recommend leaving it on with UART1 if you don't need to use UART1 for anything. If you have spare UARTs, use any of them apart from one until you absolutely run out and have to use it. That's because if you do have a problem with the USB, say for example it snaps off, you can use UART1 to then connect to your flight controller with an FTDI adapter. So it's well worth leaving that one free just so that you can use that in case of emergencies. And so there's 8 UARTs on this flight controller here. I really can't think of any reason why I'd need to use 7. So having that one as a spare is fine. And it's worth leaving it on whichever one is default on the firmware, because if, say for example, if say, well, I'm not using UART8, I'll put MSP on UART8. If I do flash new firmware to it, it's going to jump to number 1 anyway. So it's better just to leave it on whatever the default is. That way you know that you can communicate with the flight controller without any problems. The other thing I will mention is for people coming from beta flight, if you are using DJI, you do not need to activate MSP on that. You just literally use the peripheral and that's it. So I've set up my GPS, SmartAudio, my receiver. That's everything I've got on this particular plane. So I'm going to do a save and reboot. Now, save and reboot is something that you will be doing quite often, so don't worry about it. All it's doing is just saving the settings you've made to the flight controller. So the next thing that we want to do is set up our receiver. Now, I'm not going to go through the bind process. I've got videos for binding for FreeSky, so I'll put those in the description. What we're going to do is make sure that our receiver is talking to iNav. So I've got this set up to use F port, and I believe I'm using the inverted S port, so it's a regular UART. So what we need to do is just change this to use what we want. If we're using Crossfire, obviously it would be CSRF. I'm using F port, and the next thing to check is this inverted thing. Now this is a little bit confusing. If you understand a UART, you have the UART working regularly, and then you have it inverted. One of the very first videos I did was about UARTs, and it's got a little demo of how the inversions sort of look. Basically, FreeSky stuff by default is inverted, which is a massive pain if I'm perfectly honest. So when this is set to off, it's not actually saying that it is a regular UART signal. It is saying that it is regular compared to how FreeSky usually do things. So because I'm using a regular signal, not an inverted signal, I need to switch this on because it is backwards to how FreeSky do it. So it's a little bit weird to understand, but basically if it doesn't work, try switching that on and see how it goes. So this should give me a uninverted signal on the receiver, and you can see that it is working. Usually you don't need to worry about the half duplex thing. The auto works quite well. F port is a single wire bidirectional protocol, so it is half duplex. Something like Crossfire is using 2 wires, that is full duplex. But I've found most of the time just leaving that on auto works absolutely fine. The only one you need to maybe play about with is the inverted if you're using a FreeSky protocol. But there we go, our receiver is working. So what I can do now is take you through how the receiver works. Now, I said I'm not going to show you how to set up the transmitter, but I will mention that when you set up the transmitter, you need to do everything as a standard aeroplane model. So you need to have on your mix just AETR for the first 4 channels. You don't do elevon mixing on here at all if you're using elevons on your plane. There is no VTAL mixing on this transmitter whatsoever. It's just a standard elevator and rudder. You don't do any mixing on there whatsoever. That's all done in iNav. But what we do need to do is check our ranges. Now, I know I need to calibrate these gimbals a little bit, but what you want to do is if you move the stick to the right, you want 2000, and obviously we're doing the roll movement here. We want to make sure that that's doing 2000 on the roll and then 1000 at the other end. And then pitch, if we pitch all the way down, so full up, we should be at 1000, and then pitch down, which is obviously up with the stick, is 2000. And the same with your, if you go right, it should be 2000, left 1000, and the throttle all the way down 1000, all the way up is 2000. In the middle it should be at 1500, but you can see mine is slightly out. I probably just need to recalibrate this and it will be fine. The other things you can see are just switch outputs for whatever modes you've got set up. Again, as I mentioned at the beginning, I'm not going to show you how to set modes up in this video. From this we can see our transmitter is working fine, our receiver is connected, we are talking to iNav. For setting up this receiver, I do have a separate video, so again I'll put a link in the description. For example, if you find that your channels are wrong, you've probably not got a channel map right. The default mapping in iNav is AETR, so I always set my transmitters up just to use that by default anyway. But if you're using I believe OpenTX by default, uses the Spectrum channel map TAER. So what you can do is there are a couple of drop down options, but you can just type it in. So TEAAR, need to obviously save and reboot. It's just more convenient to have it on default of AETR, I find. Right, so we have our receiver set up. We're going to have a look at the next thing on the ports now, which is the GPS. So the first thing we need to do is switch it on in configuration. You notice we've selected the port, but our GPS indicator at the top is not on. That's because we haven't actually said to iNav we're using a GPS yet. We've just said where the port is to access it. So we need to turn this on. And basically I'm going to go through my default settings for a GPS, and these will probably be fine for most people. Now, by default, it's set to U-blocks. I will always set it to U-blocks 7. If it doesn't work, it falls back through to U-blocks anyway, so there's no issue with compatibility. I believe some Maytech GPSs need you to use NMEA, so double check with the manufacturer, but most GPS modules out there will be happy on U-blocks 7. The next thing is ground assist. Now, this is something that a lot of people just leave off, but unless you are traveling around the world with your plane all the time, then turn this on and set it to your region. So I will be setting it to Europe. And what this will do is actually, in some cases, it may get you a quicker fix, but it will give you more accuracy on the vertical for your GPS. So it's well worth having on. The next thing that may give you a quicker fix and more satellites is to enable Galileo. Galileo is a European cluster of satellites. So you may think that if you're in North America, then what's the point? Well, the fact is, sometimes you may be able to pick up their signal. By having this turned on, it does not affect the performance of the GPS whatsoever. But if it does find those satellites, it does give you more connections, more satellite locks, which means more accuracy, and it's just generally better. So there's no reason not to turn this on, basically. It's like 3 extra satellites if they're above you. The next thing that is quite handy is the time zone. Now, this is useful for setting the clock in iNav. So the time zone offset is in minutes. So what you need to do is take your hours difference from GMT and multiply that by 60. So for example, if you're 2 hours ahead, this would be 120. But yeah, just set your time zone in there, and then you can also turn on the automatic daylight savings. At the moment, there's only settings for EU and USA, but it's quite a useful feature for just getting your clock right. Once we've done that, we can save and reboot. And when we come back, our GPS may be working. I say may be working because it depends on your flight controller. With this one here, my GPS is getting 4.5 volts through the USB from the flight controller. You may need to plug in your main battery power for the GPS. It depends on obviously your setup. But you can see we have a blue icon here, so everything is wired up fine. The next thing that we'll do is go into the GPS tab. And you can see it's already sort of homed in pretty nicely. I've got 3 to 4 satellites, but looking at the position, I'm indoors. These are all brick walls, and the only window is sort of over in that direction. So it's picking up satellites quite nicely for a GPS module that's not supposed to be that great. So what we're looking for down here is this total messages. If this number is going up, everything is wired properly. Even if you aren't getting any satellites whatsoever, if that number is going up, then you are communicating with the GPS module. So going outdoors or something like that where you've got clear open access to the sky, you should get a lock. Remember, if this is the first time this has been powered up for a long time, it may need to re-get the almanac from the satellites, and that can take time. So you may find that the first time you use it, or the first time you use it in a while, it may take longer to get a fix, but after that it should be pretty quick. But as long as that number is going up, then it's all good. The only reason that really shouldn't be going up is because you have the wrong protocol here, or because the RX and TX wires are backwards. This is a standard UART. You basically have something that's listening and something that's talking. So on the GPS, you have an RX and a TX, and on the flight controller, you have an RX and a TX. The TX is the transmitter, so that's talking. The RX is the receiver, so that's listening. So the TX on the GPS needs to go to the RX on the flight controller. The TX from the flight controller needs to go to the RX on the GPS. That way they can talk to each other. So that's how you need to set up UARTs. So next up, what we're going to do is add some flight modes. And I'm sort of doing it in this order so that we can actually test things later on. So what we're going to do is pop in modes, and we're just going to add our modes. So the first thing I'm going to set up is my arm switch. I know that's on channel 5, and I believe that that is the correct range for it. I do have a slightly weird setup on mine, so I need to check a few switches, but yet that's all good. So basically the way it works is when this lights up, it will either be a light blue or a dark blue, depending on whether the flight controller can get into that mode at that time. So you can see down here, acro is light blue because it is enabled, and that is what the flight controller is using right now. The arm is a dark blue because we are in the range, but the flight controller can't arm at the moment. Obviously, it is a safety thing stopping it. If I unflick it, you see it's grey, which means it's not working at all. I can actually bypass. Well, you should be able to bypass. Oh, yeah, I need to save it, don't I? All right, so if I save it, now we are bypassing the arm. That's because I'd already flicked it a few times. But you can see this triangle up here saying that it's armed. And we're now light blue because we're bypassing the safety features. So we'll disarm that. So next up, we're going to set up some flight modes. Now, again, I mentioned that I'm not really sort of preaching what modes you need to have or how you set up your transmitter, but it is better if they are all on one channel. That way iNav is being told which flight mode to use, not given a couple of choices. But I'm going to just quickly set up my flight modes. In iNav, you can have multiple OSDs. Now, this might sound like it could end up being confusing, but actually it's more the opposite. It's more liberating. What I tend to do is set up my default OSD, and that will have every bit of information that I could possibly want on it. It also has GPS coordinates for if I have an emergency. There's a bit of code that you put in the CLI, which I'll put in the description and flash up on the screen, which means if you go into failsafe, it will automatically switch to the default OSD. So I only ever put the GPS coordinates on the default OSD. The way I set mine up is so that for each OSD, you get less and less information on there. So it just basically, as you change your OSD, you have more freedom of view. So it's really nice. And the final one I use is the tuning OSD, which again, I've covered setting up a tuning OSD in another video for in-flight iNav tuning, so I'll leave a link for that. But also the iNav Fixed Wing Group Pro model already has this built in too. So the first one I just have as the default OSD, and then I believe they're at 2000 intervals. Then as I rotate my pot, I've got it set up as a curve, so it just jumps. So I have default OSD, alternate OSD 1, alternate OSD 2. The next position I use OSD off because this has got the absolute least information on it at all. So you're going full flight information to the minimum what you need, then no OSD at all. And then the last one I set up for the tuning OSD.
Manual tuning off.
So that is how I set my OSD up. So now we have our mode set up. Remember to click that save button. We can go and check out our outputs. Right, so the first thing that we're going to do is make sure that we don't have any propellers on the plane. This is a safety feature. If we're working on the plane and we're going to connect main power, unless we need the propellers on for some function, like maybe getting that sort of tipping point for auto launch or for calibrating the current sensor, you should take your propellers off if you're going to plug in your main power. So the first thing that we want to do is enable motor and servo outputs. And what that will do is say to iNav, right, we can actually send information to the servos and the motors. Next thing that we want to do is set up our ESC protocol. Now, these are just using standard ESCs, but if you're using a quad ESC, you'll most likely want to be putting it on DShot 150 Obviously it needs to be BL Heli 32 and support D-Shot for this. But you don't need to go any higher than 150. And in fact, it's recommended that you don't. Having the slower speed will lead to less potential data problems when you have long runs of signal cable. So if you're using D-Shot, go for D-Shot 150. But for this model, I'm leaving it on standard. Now, the servo refresh, for a lot of cases, especially with PMP planes, you would leave this on 50. If you have full digital servos throughout the plane, which are capable of the higher speeds, you can change this up. For example, the Hewing F01 with the professional PMP kit comes with digital servos that can take the full 330 Hertz. If you're in doubt, leave it at 50 Hertz. Stop motors on low throttle, yes, you want to leave that on for planes. The number of poles on the motor, you can go through and count the magnets if you wish, and adjust that number. I believe it's only really for D-Shot. Right, so once we've done that, what we can do is test our servos to make sure that they're all working correctly. We've obviously set our mixer, but sometimes, you know, depending on which way around the servos are positioned in the wing, then it may not be right. So if this is the first time plugging a battery into your plane, you will want to get something like this. Now, this is an invaluable piece of equipment, and they're generally called smoke stoppers. And what this will do is, if you have any electrical problems on your flight controller, it will trip a little fuse in this so that you don't get any power going through to the flight controller. And that will actually save your flight controller letting out the magic pixie smoke, which we don't want, do we? So they're really simple to use. Plug in the smoke stopper, just plug the battery in. Of course, it does help if you remember to save and reboot after enabling the outputs, doesn't it? So we'll just do that, and then I'll plug the battery in when we come back. And then I've just heard the servos move, and then we get our startup tones on the motors. Right, so the first thing that people seem to be dying to do when they plug in a battery is see if the motors work. And the first thing they'll try and do is arm and then use the throttle. That won't work. As I mentioned, there are safety things in place, and the simple fact is you don't need to do that. If we go to the receiver page, if our throttle is moving here, down is 1000, up is 2000, everything is fine with the throttle. We don't need to worry about using the transmitter. iNav knows what to do with it. If we want to make sure that the motors are working, and more importantly that they're spinning the right direction, we can do that in this outputs page. So we just need to enable that, obviously make sure your props are off, and then we can raise this slider here. And there you go, the motors are working. And what we can try and do is raise them up slowly, just to make sure that they're going in the right direction. All right, so I saw that one starts up that way, so that's good. This one is going that way, so they're both spinning inwards, which is exactly what I want on this plane. What we're going to do is look at the servos now. So we need to check that our servos are moving the right direction. So for this, we're going to make sure we're in manual mode, and we're going to do a basic high five test. So if we roll over to the right one should be going up, and the left one should be going down. So they're backwards. So what I'm going to do is just reverse them in here. We'll do a save, and we can see that they're working correctly now. Now we need to test the V-tail. So if I pull backwards, they're going nose down instead of nose up, so they need to be reversed. But the yaw is actually correct. So in this instance, what I'm going to do is just pop into the mixer, and on the stabilized pitch, I will reverse the negatives. So if I do a save and reboot, this should all be working correctly. You do not reverse anything on the transmitter whatsoever to get your control surfaces moving. The only time you ever reverse something on the transmitter is if you push this, like push a stick to the right, but it actually goes down to 1000. It needs to be right or up is 2000, left and down is 1000. That's, you do not ever reverse anything in a transmitter for the 4 main channels, only for getting that right. Right, so anyway, let's check our V-tail again. So down is now nose up, up is now nose down, so that's correct. So it's basic high 5 test, and the rudder is still moving in the correct direction. So that's all good. We know in manual our control surfaces are correct. Next, what I'm going to do is put it into angle, and we'll go through the same test. Now, because the board alignment is correct, the receiver is set up correctly, this should be identical. If you find you have a problem where they move different directions than they in angle than they do in manual, you've got something wrong either in the mixer and the transmitter, in the receiver page, or on your board alignment. It's nothing to do with reversing, but I will just show you it. We know that all that is correct on this model. So if I roll to the right, we can see that's up, that's down, that's correct. Roll to the left is obviously the opposite. Pitch up, we can see both of these are going up, and pitch down, they're both going down. Rudder to the right, they're both going to the right. Rudder to the left, they're both going to the left. So that is working perfectly. Now, you would have noticed that there's quite a bit of difference in the movement between angle mode and manual. Don't worry about this at all. This is purely because the feed forward has not been tuned yet. There's a default value which is safe for getting you into the air and flying, but it hasn't been tuned yet. That's why you use the auto tune in acro mode to get you tuned. We know that our outputs are working correctly from the receiver. Everything is moving in the right directions. The only thing that we have left to test as far as this goes is the stabilisation. So again, we're going to stick it into angle mode. I'm going to shove the battery in here and hope that the USB doesn't disconnect, because in this model it's magnetic. That's the only way I can get it in there. And what we're going to do is just watch our control surfaces basically. So if I pitch the plane down, what we want to see is these control surfaces here pitching sort of upwards so that it puts the nose up, which I don't know if you can see on the camera, but it is doing. So they are both going up to try and bring the nose back up. If we go the opposite way, they should go down, which they are doing to bring the nose back down. If we roll over to the right, so this is obviously not commanded, we can see that this is going up, that's going down, which if we want to bring it back to the right, that is the correct direction to go. We can see by, if I move the stick more to the right, it actually carries on going the same direction that the stabilisation is going in. So that is correct. So we know that our stabilisation is correct. Stabilisation on the yaw. As you can see, when I rotate it, it's hardly moving. Testing the yaw is a bit trickier because it's hard to see what it's doing. In iNav 4, if I pop into the PID tuning, you can see that on the yaw we do have proportional. We have 0 derivative, so it doesn't trim the servos on the yaw, and there's also no derivative because it's not really needed. It just has a bit of proportional for stabilization for wind gusts. And what we can do is set this up quite high. So if I set this up to 50, and if I give us 200 on the feed forward, we should get a lot more movement on the control surfaces. So what we want it to do is, if the aircraft is rotating to the left, we want to obviously yaw to the right. The control surfaces here want to move the opposite direction to the nose, or the same direction as the tail. So if the tail is moving this way, we want both of these to go this way. And the easiest way to do it is to try and feel it. So it's not a visual thing, but you could, if I move it this way, I can feel this pushing up against my thumb. So I know that the stabilization is working the correct way. Once that's done, we should obviously reset these back to 120. So there we go. We know our stabilization is working correctly. As I said, it should not have any issues. If manual and angle are putting the control surfaces the right way, if the board alignment is correct, then everything should be working as it is here. So we're pretty safe to say that all our flight mechanics, if you like, are working correctly. So I've just disconnected the battery and we can carry on with the next parts of our setup. So the next thing that we need to set up is failsafe. We obviously want this thing to come back to us if we have any problems with our receivers. So you will need to obviously set up the failsafe mode on your receiver first. Now for FreeSky, you would either use hold or no pulses. Both will work. I've used both in the past with no problems at all. But yeah, hold or no pulses. They both send the failsafe bit to the flight controller. So the flight controller will basically do the work for you. If you're using Crossfire, it needs to be set to cut as the failsafe mode. And again, that will send the failsafe bit to the flight controller and it will take over. So how do we set iNav up to use return to home? Well, we go in this failsafe tab and we click return to home and we click save and reboot. So at this point, if I actually click save and reboot, so at this point iNav knows that if there's a failsafe that we need to use return to home. But what we really want to do is make sure that failsafe is actually working. As I mentioned, you need to set your receivers up. So with FreeSky, it's no pulses or hold. With Crossfire, it's cut. And if you do, it should work fine. But we're just going to do a little check now just to make sure that everything's okay. Obviously, the transmitter is turned on at this point. And if you look in iNav, there's this parachute which says failsafe mode if you hover over it. What we're going to do now is turn off our transmitter. If you get a warning saying that the receiver is still connected, just press enter to actually shut it down. And at this point, what should happen is this parachute should go red, which it has. So we're in failsafe, iNav has detected it and it's all good. So check 1 has passed. Now what we're going to do is turn our transmitter back on. Of course, you'll need to skip any warnings or whatever for switch positions, which that's okay. Once the link is re-established, our parachute should turn grey again. If when switching off it goes red and when switching back on it goes grey, everything is set up correctly, so iNav will detect the failsafe. So we've set our failsafe mode to return to home, but what we need to do next is actually set up return to home. So here we go into the advanced tuning page. Now I'm not going to cover this in great detail because I've done a video separately on return to home. So if you want to check that out, I've got a link in the description so you can pause this video and jump out into that video. But as a very, very quick and basic overview, the settings are at the bottom of this advanced tuning page. You have a return to home mode, which is completely dependent on your flying environment. Likewise, most of these settings are dependent on your flying environment. So I would highly recommend watching that video so you can make the best choices for where you're flying. But there's a couple of things that I'm just going to set this up for me. So I'm going to have at least with linear descent. So that means it will fly home at, use centimeters, don't do a Hoffman. Right, so at least linear descent will mean that it will fly home at least 110 meters above launch point. If it's above that, it will stay at the altitude it's at. If it's below that, it will go up to 110 meters. The linear descent part means that on the way back to the home point, it will gradually reduce altitude. Ideally, the target is so that when you get to home, you are at the 110 meters altitude, whatever you've got set in this box here. RTH home altitude is the altitude that it will loiter at once it gets home. So I bring this down so that it's easier to see basically, but keep it above tree height. It's very useful to set the home altitude even if it's the same as the return to home altitude, just because some of these modes you could be higher than your return to home altitude. So when you get home, this will just make sure it comes back down so you can see it. Climb before return to home, I leave on. Again, this is something that you need to set up based on your environment. I never really touch these. The override is quite a nice feature. It means that you can, on return to home, if you want to just come back at the altitude you're at, you can use the pitch stick. And if you want to change from climb first to turn first, you can use the roll stick. It's quite a nice little feature. Land after return to home is set by default to failsafe only. And that's what I leave it on. Now, the land is a controlled crash if I put it quite basically. It will basically loiter down until it gets to ground level, or what it believes is ground level. An example of why this could be bad is a flight that I had last weekend on Sunday, where I was literally skimming the ground, probably about, maybe 10 centimeters off the ground at some points, maybe even lower. And my barometer was reading that I was 40 feet up in the air. This is obviously because of the cold temperatures that we have at the moment. It's getting cold, then the inside the fuselage is getting warm, and it's obviously having drift with the barrow. But if it's using that barrow to determine where the land is, it's obviously going to cause problems. The other thing that I've sort of mentioned was it's dependent on your loiter radius. So default loiter radius is 75 meters. For you to land, you need at very least 150 meter circle on the ground with your arming point in the center. You can use safe homes, so you can set it up so that on failsafe only it will use a safe home, which is a better option if you don't have the area around you. So from where I launch my plane, there's probably maybe 30 meters. So I've got a quarter of the loiter circle where I arm it. So there's absolutely no chance in hell that I can land that plane with failsafe there. So I have to use a safe home, which I've got in a position where it's got the least chance of hitting something. It's the flattest, most open area near where I fly. But I do, as I say, only use those with failsafe. And I don't have failsafe on a switch. I just have return to home. I just bring it in and land it myself. But this gives the option, if I have no control, it will come in and it will try to land the best it can in the best space available. So that is really all I'm going to cover with return to home. If you want more information and you want to know about all these different modes, the different options with climb first, then check out the other video. Right, while we're on the advanced tuning page, you'll see that there is auto launch settings. Now, again, this is going to be very particular based on the type of plane that you're using. I have a reasonably old video on auto launch. I plan to update it at some point, but most of these settings are the same. You've got the end time, which is new, and all the end time does is how long it takes to transition over from the top of the launch. Originally, it just sort of got to the top of the launch and went flat, but this just gives it a nice sort of rounded transition. All the other settings are basically the same. The order on this screen is different, but the actual settings are the same. The fixed wing navigation settings, I would highly recommend watching the series I did with Mark Hoffman on tuning iNav. This is sort of more relevant again now because as of version 4, iNav auto tune doesn't tune anything on the PID controller. It just tunes the feed forward and the rates. So if you did want to manually tune your plane, you sort of need to understand that a little bit again. And one of the videos we do actually cover these navigation settings. There's a couple that I will just point out, but I'm again not going to go into detail. So cruise throttle, you will want to find out the best cruise throttle your plane flies at and then set that value in here. Obviously, you always need to be able to make progress. So don't just set this at the lowest amp draw possible, because then you could find that all of a sudden you're into a headwind and you're just not going forwards. So you need to set this at a reasonable cruise throttle. This can be adjusted in flight using adjustments. Min-max throttle are the minimum and maximum throttle that the auto navigation can use. Loiter radius, so by default it is 75 meters, which is probably a nice average for most aircraft out there. Bigger aircraft will probably need a bigger circle, whereas smaller, more agile aircraft could have a smaller circle. But again, you need to sort of base this on flight experience with that craft. Loiter direction, you can set this as a hard-coded, I want to loiter all the time to the right or left, or you can use yaw, which is what I typically use. So with yaw, it will default loitering to the right. If you decide you want to loiter to the left, you just move the yaw stick to the left. If you change your mind, you can move it back to the right. So you've got that choice of loiter direction already built in using the yaw stick. And yeah, that's where I'm going to leave it, I think, for these settings. So I'll save and reboot, and then we'll move on to the next area. Right, so the next thing that I'm going to go through with you guys is OSD. Now, this is something that is personal and people just set up OSDs as they like them. But there's a few things that I can sort of recommend or suggest or go through. Right, so there is a very important thing that we need to do every time we set up a new flight controller and potentially every time we change iNav version, and that is to upload the font. If you don't do this, you can end up with all sorts of weird symbols. So basically just go through and choose the font type that you like the best. There's a few different options. I actually just like default, to be honest. I'm quite weird. And then just click upload. It will then upload the font to the flight controller and will come back once it's rebooted. So there are some other options on this side that we can talk about, but some of them are easier to discuss when we actually have a sort of layout already set up. One thing I will mention is this video format. You can leave it on auto, in which case it will try and match to the camera, but it's better to actually specify PAL or NTSC. And you can see why here, because there is actually different space available depending on what system you're using. And also we have HD now for HD0, which has a nice amount of space available. So I'm actually really tempted by HD0, I must say. DJI not having a proper OSD is just a no-go for me. But yeah, I am tempted to try that out. But anyway, I will go through the analog process using PAL. So I'll save that. And what I'm going to do is I'm going to quickly just set up my OSD, and then I'll come back. I'll potentially discuss a few things why I've got them, but we'll also go through the options on this side, and I'll also show you how you can make setting up the alternate OSDs much quicker and easier. Okay, so this is basically my default OSD. There's a few things that I have on here that I don't have on other OSD screens, such as the plus code, which is obviously used for locating your craft in emergencies. But as I mentioned earlier, there is that command so that you automatically flip to the default OSD in a failsafe, but also you can get your GPS coordinates on your transmitter quite easily as well. So there's not really much reason for having them on any other OSD. Now you can have extra length on the plus code to get you a more sort of honed in position, and that's all changed on this side here. So what I'll do is I'll just go over a couple of things on why I have them. So I have cell voltage and full battery voltage on my first screen. Most of the other screens I just have cell voltage, but I have both voltages on the default screen just so I can double check that they are sort of matching up. The number of satellites and the HDOP, just to make sure that that's all good. The RSSO and the flight mode I keep on most screens. If we come down to the bottom, I mentioned the plus code. I also have the time. Just, yeah, sometimes I want to look at a clock. It's like, do I have to be home soon? We get obviously carried away, don't we, when we're flying? So having the time on a OSD is quite useful. The VTX settings, so I have the full VTX settings on this default screen. So I have the channel and the power, home direction, home distance, and the fly time and on time. So when you're not flying, it's the on time. When you're flying, it's the flight time. In the middle, I do have the artificial horizon, the crosshairs, and the side ladders. I have got the RPM, which obviously doesn't work on this model, and usually I'll set that to 4 or 5 precision. Next one, I have throttle position and auto throttle. So in regular flight, this will be your throttle position, and in navigation modes, it will be auto throttle. I have got the ground speed and I have got the 3D speed. The 3D speed is actually really useful for especially larger aircraft. You may have seen a video posted by Wesley Varty where he had a crash with his Believer. He thought it was a stall, and that was based on the fact that he only had ground speed on the OSD. So it looks like he was going pretty slowly, but in fact he was actually in quite a steep dive. So the 3D speed was 150 kilometers an hour, at which point he suffered what we believe the most likely scenario is aileron reversal, which is what instigated the roll. It was rolling too slowly to be a stall. So it definitely wasn't a stall, and the control surface was still intact, so that's the most likely option. This 3D speed got up to in excess of 200 kilometers an hour, so you can see it's very useful to have a 3D speed there to just make sure that everything is great. The other side, I have the altitude and I have the numeric variometer, and this was what I was mentioning with the auto level. You'll watch that and it will just be plus minus a very small amount once it's all tuned in. So that is my basic OSD. And once you're happy with your OSD layout, don't forget to obviously click that save button. Now, we did set up alternate OSD layouts, and at the moment you can see that they are blank. And as I sort of mentioned earlier on, I can show you now a way of getting these so that it's much quicker and easier to get this updated. So what we're going to do is go into the CLI and we'll type OSD_layout. And this will give us our OSD layout. So I'm just going to copy that to the clipboard, and I'm going to go to my website where under useful tools I have the iNav OSD switcher tool. And all we need to do is put our CLI code in here, and we're going to choose the layout we want to start from. So in this case it's default, and the OSD that we want to move stuff to, so alternate layout 1. We're going to copy in this case, but we can swap them over, we can add elements from that one to that one, or we can move. So we're just going to do a copy, so we click the update button, copy that to clipboard, and we're going to go back into iNav, and all we need to do is paste it because there is a save at the end anyway, so we just wait till we get back to the OSD page. So now we're back at the OSD page. If I move to alt layout 1, you can see it's exactly the same as default. So what we can do is start getting rid of things that we don't actually want. So now we've got less things on our OSD, we can actually reposition them so that they're a bit less cluttered. So there you can see we've already moved a lot of stuff around, but a lot of things are in the same position, so it's, yeah, we don't lose where they are on screen. We don't have to go searching for them. And then we can save that, go back to CLI, OSD layout again, copy to clipboard, go back to our tool, clear that out, put our new code in there, and this time we're going to copy from alt 1 to alt 2, update the OSD, copy to clipboard, back to iNav. You can see this is pretty similar process, but what we're going to do is on alternate layout 2 is get rid of even more stuff that we don't want. Right, so we have our full layout on default, alt is less, alt 2 is the same as alt. So now what we're going to do is get rid of even more. So there you go, we have now a much more clear view of the sky. Obviously the next position on that switch is no OSD at all. So you can see the nice progression from having lots of information to having none. Obviously the alternate layout 3 I use for a tuning OSD, which I will cover in a different video. I'll put the link in the description for that. And obviously it's included with the iNav Fixed Wing Group Pro model. That should be everything you need to know about setting up your OSDs. Of course, remember to click that save button. Right, so we're basically there. One thing that we can do though is we've obviously set up our OSD, but is our camera working? Is our SmartAudio working? Let's have a look. Get that plugged in again and let's do a search. Okay, so there we go. We have a picture. If I can reach, there we go. We can see that's all live, and I can rotate this pot to show the different OSDs. So we can see that that is all working. What we can do, I don't have any switching set up on this at the moment, so I can go into configuration, and we're on Fat Shark 1 at the moment, so I can see the VTX powers on 1. Let's go back to here. So it's on Fat Shark 1. Let's choose a different band, different channel. I'll leave a power level on 1. Do a save and reboot. And we shouldn't get any picture. There we go. So let me retune. And there we go. We're obviously on a different channel because I needed to retune the VRX. So SmartAudio is working. So we know that everything is good to go now on the video side. Our OSD is fine, our picture's fine, and our SmartAudio is good. So that's all done. The only other thing that I can really mention is the current sensor. So it is worth using a multimeter to first correct your voltage scale, and then you can correct the current meter. I do have a video for this, and it's using another tool on my website. So iNav current sensor calibration. But basically you will take this current meter scale, put that into that box, make sure that the offset is at 0, and then what you're going to do is just put the props on. So it is a little bit risky. What I usually do is put the props on and then put the nose down into the desk, so it's trying to fly into the desk. That gives me a little bit more confidence, but also you can make sure the cables are out of the way, it's all good. And what you need to use is either a clamp meter or a specific current meter like the Toolkit RC watt meter. And what you're going to do is go to the outputs page, enable your motors here, and what you're going to do is just give it a little bit of throttle. Obviously I've got no props on this, so that the current is not actually going up, but the first reading, just make sure that it's over 1 amp. They all need to be over 1 amp, and you'll put in this number here into that box, and whatever it says on your current meter in that box, and you just take a few readings at different throttle settings, all of them above 1 amp. Click calculate, and it will give you a new scale and a new offset, and that will get you pretty close to bang on in most cases. The only other thing that may be helpful to you while I'm talking about the website, we have a pre-made checklist. So once you've got everything set up, and this is good for if you've done an update as well, you can go through this checklist just to make sure that the things that usually catch people out won't catch you out. The other thing that I can mention is the auto launch throttle calculator. This is a basic tool to try and get you the values for auto launch. So if I go into advanced tuning, we have an idle throttle and we have a launch throttle. This is calculated based on where you live, the average altitude of where you live, the average temperature of where you live, and it uses that to calculate the average barometric pressure. So there's a little bit of smart stuff going on in the background, but all you need to do is put in your prop size, which I think on this is 7x4, how many blades there are on the prop, the kV of the motors, the number of motors, S rating of your battery, so this is going to be using 4S batteries, and then an approximate weight of your model, and just click calculate. And what this will do is give you a starting value for the launch. So it's recommending 1680 for the idle throttle and 2000 for the launch throttle. Now this is an estimate. You will want to test this as you would if you were just sort of picking these numbers out of the air yourself. But from what I've seen on reports, it has been pretty accurate. So it's a good starting point. If you don't feel confident holding the model upright with the props spinning, just to try and get that buoyancy point for your throttle, then this tool will help you out there. So that is the basics of setting up iNav. Actually, it's gone a little bit further than the basics. I've covered more things on here than are probably needed for a very base setup. But this should at least get your model so that you know that it's going to be pretty safe on the maiden. Just double check everything. The one thing I've not covered is setting up throws. Again, I have covered that in another video I'll put a link to. It's very important to get the throws correct on these models. And unfortunately, a lot of manufacturers don't include them in the instructions, which is something I really hate about a lot of these manufacturers. But other than that, the basics of iNav are now ready to go. Obviously, for basics, you don't really need to do the current sensor calibration. If you're doing a manual launch, you don't need to worry about auto launch, but these are extras that we've sort of added on the video. And I would recommend when you're setting your plane up, you can go through with this video, but it's worth having the article as well. So thank you very much for watching, guys. I really hope this video helps you, and I hope you have a blast flying with iNav. Please remember to give it a thumbs up, click the subscribe and bell icon. That will give you alerts for more videos that may help you in the future. It will also help get this video out to more people so that they can learn how to do this too. Thank you very much, guys. Fly your models like you stole them. See ya.